Hello everyone, today we'll be trying to solve a problem. I have already drawn the problem here and also mentioned the problem. The problem states that I have a wedge of mass capital M and I have a block of um, small m, and what I gotta do is apply a force, capital F, on the wedge, and I'll apply the force in such a manner that the red block or the block with mass small m does not slide along the surface. Of course, I have also considered the surface to be frictionless, and thus what I really mean is with respect to the wedge, the red block will be stationary. That's what it really says. Okay, we need to find the force and also find the total acceleration of the system. Total acceleration of the system, by system I mean the block and the wedge both as a whole I'll consider as a system. So let's start. At first we can draw the free body diagram of red block M, for which I think I should remove these words. Okay, so at any moment there will be a normal force acting on this small m, the red block, and I will denote it with big N or the capital N. Okay, there is also another force acting on small m, which is the gravitational force. It's acting downward with the magnitude mg. And are there any other forces here on red block M? No. So we can just start drawing the free body diagram for this red block. Okay, so this is the particle and this is the normal force and this is the weight, and the acceleration is, as I have stated already, is in the right direction. And okay, so m, and clearly the net acceleration is in the right direction, so the net force must also be in this direction, right? So the sum of these forces should be in the right direction. Okay, and let me draw this one here. I'm drawing a parallel line to the horizontal, so we're going to denote this angle as, let's say, alpha. So the angle that this thing makes will also be alpha, and now we can start, of course, and this will be 90 degrees. So of course this angle, I'll remove the m, so of course this angle is 90 minus alpha. Okay, done. Okay, so I will consider this to be the x direction, the x-axis. Okay, so normal force. Okay, the angle here is 90 minus alpha, and I'm going to denote the vertical axis as axis y. Okay, so there will be two equations. Summation of f of y is to be equal to 0, and which means that if we consider this to be the positive and this to be the negative direction and this to be the positive and this to be the negative direction, then n, the sign component of n, will be neutralizing the weight mg, and summation of fx should be equal to m a net. Okay, so we have got two equations here, so we can break it down and we will find that n cos alpha is equal to mg. So n is equal to mg sec alpha. Okay, we found the n, and we can use this later on. So is equal to, as we can see the forces, I can denote this F net on M, the small m, Of course, we're talking about the small m here, or the red block. So the cost component of normal force will be in this direction. So n cos 90 minus alpha, and there are no components of any other force in this direction. This is the only force that has the component in the x direction. Okay, so we find that n sine, from here I mean, n sine alpha is equal to m a net. Okay, we've already found what n is, so we can replace that, I mean substitute that. So mg sec alpha sine alpha is equal to m a net. So this will be equal to tan alpha, and we will find that we can cancel out the m's, and we will find that a net is equal to g tan alpha. We have already found a portion of our answer. Now what we can really do is consider this whole thing a system. Okay, so the force F is acting on this system. So this is the system, and the force F is working on this system, and the total mass of the system is m plus m, I mean the small m plus big M or capital M, whatever you say, and the direction of force is in the direction of direction of acceleration is in the direction of force, and the magnitude is a. So what we can really say here is F is equal to m plus m into a. And I should actually recall that we have told that the box is moving in the right direction with the acceleration in it. I should have said that that the acceleration in the right direction is a rather than the in it. So it will actually be a. So I'm going to change the acceleration everywhere. Okay, not in it but rather a. So okay, so now we can substitute a here. So F will be equal to m plus m into g tan alpha. This is the final answer. Another thing to note, there is weight acting down, m plus m into g, but this has no component in this direction, I mean the right direction, so therefore it does not affect this equation at all. Bye everyone, thank you for watching, see you later.